Okay, now, so we're talking about initial equation. So first of all, what is an initial equation? So take down. These are equations in which what the index or what power are what unknown. The index and the power are unknown in an initial equations. So what's the way forward? They are solved by what expressing both the left hand side and the right hand side in the same base. Therefore, the same base will be cancelled out and the power will be written as what? The answer. So that's what initial equations are. Is the equation where the what powers or the index are what unknown. Of course, you express what the base of between the left and the right hand side, express them as the same base, then cancel the base out, then the power will retain the base, right? It will be the answer. So that was the concept. Now let's start with solve the following. So let's say let's have solve the following. Of course, let's have question number one. We had 2x is equal to what? 16. 2x is equal to 16. Now we say that what the power are what? The unknown in this case. The powers are always what? The unknown. How do we make the power that is unknown? How do we get the answer? That was the concept. So therefore we express what? The base of each term. We express the base in the left and the right hand side as the same. Then what? We cancel them out and what? We retain the power as what? The answer. Now let's take this out. So we have 2 raised to the power x. How will we make 16 look like 2? Because the concept is what? To make these two look the same. So you can successfully cancel them out. Of course, the concept is easy. We know that 16 can be expressed as what? 2 raised to the power 4. So we're going to rewrite this in terms of this. So we have 2 raised to the power x is equal to what? 2 raised to the power 4. We have successfully made these two look like, right? The next step is what? Cancel this out. If you cancel 2 out, we have what? X is equal to what? 4. That's the concept of what? In this equation. Let's take the second one. Of course, we have 4 raised to the power x plus 1 is equal to what? 8x plus 2. Now we said what? Make the left hand, the right hand side look the same so you can successfully cancel them out, right? Now we can express 4 as 2 raised to the power 2, right? And we can express 4 as 8 as 2 raised to the power 3. So when we do that, it becomes 2 raised to the power 2 bracket x plus 1 is equal to what? 2 raised to the power 3 bracket x plus 2. So when we have 2 multiplied by this, it becomes 4x plus what? 2. Sorry, this becomes 2x plus 2 is equal to what? 2 bracket what? 3x plus, of course, this is plus 6. So you can see that this will cancel this. You now have a linear equation. So you're having 2x plus 2 is equal to what? 3x plus 6. Of course, the concept is move this to the other side and bring the 6 to the other side. So this becomes what? You're going to bring the 6 to the other side. So it becomes 2 negative 6 is equal to what? 3x, bring this to the other side, negative 2x. So 2 negative 6 is what? Negative 4. Of course, 3 negative 2 is 1 becomes x. So therefore, we have to rewrite this and we say that x is equal to what? Negative 4. That's what's the concept. We have the third one. Of course, we have 16 raised to the power 3 plus x is equal to what? 1. How can we express 16 in terms of 1? Or how can we express 1 in terms of 16? What is your say on this? How can we express 16 in terms of 1? Or how can we express 1 in terms of 16 so they can successfully cancel them out? Trickish, right? But we said that under the laws of indices, that anything raised to power 0 is what? 1. In this case, let x be equal to 16. So you have 16 raised to power 0. This is equals to 1. So with that concept, we're going to write this as what? 16 3 plus x raised to power 3 plus x is equal to what? 16 raised to power 0. So therefore, this will cancel this. Of course, they have the same base. It becomes what? 3 plus x is equal to what? 0. So therefore, x is equal to negative 3. So that's also the concept. Very important concept. Very important. So let's take the fourth one. Of course, we have 27 x plus 2 is equal to what? 9 2x. 9 x power 2x. Of course, 27 is a multiple of 3. 9 is a multiple of 3. Rewriting this, we have 3 raised to power what? 3 bracket x plus 2. Of course, 3 raised to power 3 is 27. Of course, 3 raised to power 2 is what? 9. So opening the brackets, we have 3 raised to power what? 3x plus 6 is equal to what? 3 raised to power what? 4x. So this will cancel this, and you have what? 3x plus 6 is equal to what? 4x. That was the concept. And now we can eventually write this as what? When we bring this, we have 6 is equal to what? 4x negative 3x. So therefore, x is equal to what? 6. This is the concept of Indicial equation. Now let's take 5. We have 9 raised to the power 2x plus 1 is equal to what? 81 raised to the power x negative 2 over what? 3 raised to the power x. Now we're going to what? Write them in terms of 3. Of course, this is becomes 3 raised to the power 2 bracket 2x plus 1 is equal to what? This is 3 raised to the power 4x negative 2, and we have 3x. Of course, opening everything, we have 3 raised to the power what? 4x plus 2 is equal to what? 3 raised to the power 4x negative 8 over what? 3x. What do you notice here? Since these are what? The same. First of all, let's break this down first. Let's work on this first. So we're having, since they're the same base, this becomes 3 4x negative 8 negative x. So we have rewriting this, we have 3 raised to the power 4x plus 2 is equal to what? 3 4x negative x. This becomes 3x negative 8. So you can see that this will cancel this, and you have 4x plus 2 is equal to what? 3x negative 8. This will come to this side. You have 4x negative 3x is equal to what? Negative 8 negative what? 2. So you now have x is equal to what? Negative 10. So this is the concept of indices. Of course, we have number 6. Of course, we have 27x all over what? 81 bracket x plus 2y plus bracket close is equal to what? 9. And we have x plus what? 4y is equal to 0. So therefore what? This is a simultaneous equation involving indicial equation. So it's very important. The concept is easy. You play with this and simplify this and make it what? A linear equation. Then you take the you compare this, and this becomes equation 1, this becomes equation 2. Then you solve them simultaneously. So we're going to play with this first. So we're having a case. So we're having a case where we're going to work with this. We're going to simplify this and make this look like this. So in this case, we're having of course, 27 can be expressed in terms of 3 raised to the power what? 3x all over what? 3 bracket 4x 2y. This can be expressed in terms of what? 3 raised to the power 2. So of course, we're going to play with this first. This becomes 3x of course over what? 4x plus what? 8y equal to what? 3 square. So this becomes we're going to work with this first, because we know that this can express as what? 3x negative 4x negative what? 8y equals to what? 3 raised to the power 2. So you can see a case where this will cancel this, and you have what? 3 negative 4x negative what? Okay, we have a case where you have 3x negative 4x negative 8y is equal to 2. So therefore, this becomes what? Negative x negative 8y is equals to 2. So when we write this, which is multiplying both sides by negative 1, it becomes what? X plus 8y is equals to negative 2. So let's call this equation 1. And we also know that what? X plus what? 4y is equals to 0. Let's call this equation 2. So the concept is easy. We are going to make one subject formula from this case with the principle of solving simultaneous equations. Of course, now let's take from equation 2. So we're having from equation 2, making equation 2 separate formula, we have that x is equals to what? 4 negative 4y, right? X is equals to negative 4y. We're going to substitute what x is. So let's call it equation 3. We're going to substitute what x is into equation 1. So anywhere you see x, you represent as what? Negative 4y. So we're having x, of course, equation 1 is x plus 8y is equals to negative 2. So anywhere you see x, you replace it as what? Negative 4y. So we're having negative 4y plus 8y is equals to what? Negative 2. So negative 4, negative 8, sorry, negative 4 plus 8 is what? 4y is equal to what? Negative 2. So therefore, dividing both sides by what? 4, it becomes what? Y is equal to negative 1 over 2. And if y is negative 1 over 2, what will be x? So x is equal to negative 4y. Substituting this becomes negative 4 into what? Negative 1 over 2. Negative will cancel negative. 4 into this, we have 2. So therefore, x is equal to what? 2. So therefore, we have what? Y as negative 1 over 2 and x as equals to 2. So that is the concept of what? Indicial equation. Of course, this is different from what we have been doing since, of course, we have a case where this is a simultaneous equation. We are given two equations, one indicial and one linear equation. We are going to simplify this to what look like a linear equation, which we did, and we have x plus 8y is equal to negative 2. Then we solve them simultaneously and find the value of x and y. Number 7. So we are given a case where we have 2 raised to the power what? X plus y equal to what? 8. And we have 3 raised to the power what? 2x negative y is equal to 27. So of course there are two equations. 2 raised to the power x plus y is equal to 8 and 3 raised to the power 2x negative y is equal to 27. Of course, we are given a case where these two questions are going to be simplified into linear equations. Then we solve them simultaneously. That's what this question is all about. Why are we doing that? Because we have two unknown in each of the equations. Two unknown in each of the equations. In the case where we have one unknown, there will not be need for us to solve them simultaneously. But in the case where they are two unknown, we are going to solve them simultaneously. So therefore, which one are we taking first? Let's have this as what? Equation 1 and equation 2. So we're starting from equation 1, expressing, so let's have solution. So we have 2 raised to the power x plus y. Of course, 8 is what? 2 raised to the power 3. This will cancel this. You have x plus y is equal to 3. So let's call this equation 3. Of course, we have made one of the equations in this equation look like a linear equation. So from equation 2, we have 3 raised to the power 2x negative y is equal to what? 27. This can be expressed in terms of what? 3 2x negative y equals to what? 3 raised to the power 3. This will cancel this. We have 2x negative y is equals to 3. We have equation 4. So this concept is easy. We have this and this. Of course, let's work on equation 3. We're going to make x a better formula from equation 3. You have 3 negative y. Let's call this equation 5. We are going to substitute what x is as 3 negative y into what? Equation 4. And so anywhere we see x in equation 4, we substitute as what? X negative x is equals to 3 negative y. I hope you get that concept. So therefore, when you have what? 2 bracket what? 3 negative y. Of course, that's what we said. Negative y is equal to 3. So we're going to open the brackets and we have what? 3 into 2 is what? 6. 3 into negative y, we have, sorry, 2 into 3 is 6, and we have 2 into negative y, we have negative 2y. is equal to what? Sorry, negative y is equal to 3. So when we do this, we have that 6 is equal to what? 6 negative 3y is equal to 3. So this will come in and this will come in. We have 6 negative 3 is equal to what? 3y. This will become 3 and we have 3y. Divide both sides by 3, we have y as equal to what? 3 over 3, which is 1. So we have y as equals to 1. We're going to substitute y is equals to 1 into what? Equation 5. We know that what? X is equals to what? 3 negative y. So we have x is equals to what? 3 negative 1. This becomes 2. So therefore, we have what? Y as 1 and what? X as what? 2. This concept of indicial equation is very important because in any equation you solve, you're having new knowledge about how these are being applied from a relationship. We have never seen a case where we have two equations which are going to simplify. We have two linear equations. What we did earlier is we have one what in this equation and we have, of course, one linear. In this case, we have known how to apply that in a case where we have two different equations that are what of the use of indices.